Okay, this presentation is going to be an introduction into reaction rates and equilibrium. After going through this PowerPoint presentation, you should be able to define reaction rate, list the indicators of a chemical reaction, and describe the collision theory. What we're going to try to do in this presentation is talk about chemical reactions, remind ourselves what are the indicators of chemical change, talk about how reaction rates are measured. Then we're going to look at something called the collision theory, and then lastly talk about real-life application of reaction rates. To get us started, let's talk about what a chemical reaction is. A chemical reaction occurs as the reactants turn into products. And during a chemical reaction, bonds are broken and new bonds are formed. To illustrate this, think of the reaction between hydrogen gas and oxygen gas to produce H2O. If you look at it on the molecular level, there's a molecule of hydrogen and a molecule of oxygen. When you bring them together and they react, they break the bonds in the molecules. Each of the atoms spread apart, and then two hydrogens and an oxygen come together to form a water molecule. And two new bonds are formed between the oxygen and the two hydrogens. How we know this occurs on a macroscopic or large scale is by indicators of a chemical reaction. We talked about these last semester and a little bit at the start of this semester, but let's refresh our memories. Some of the observations that tell us a chemical change has taken place are a change in color, formation of a gas, formation of a solid, which we call a precipitate, and a change in energy, either a temperature change or if light is emitted. Take a look at these two different reactions and see if you can make observations as to the indicators of a chemical change. In this first reaction, we see a color change and the formation of a precipitate. And in the second reaction, we see gas produced and a change in energy, both in heat and light. Now what we're going to do in this unit is look at something called reaction rate. What reaction rate is simply is how quickly reactants turn into products. We can measure this a couple of different ways, but one way is to measure the formation of product over time. Another way to measure reaction rate is by the amount of reaction used over time. Some chemical reactions occur very quickly, as in this example of potassium in water. It's also very violent, releasing a lot of energy. Other reactions occur slowly, like when silver nitrate and brass react. This is a time-lapse photo over several minutes to show the reaction. All chemical reactions are based on the idea of the collision theory. The collision theory states in order for molecules to react, they must collide. But not only collide, it has to be an effective collision. And what chemists mean by effective collision is that when the molecules come together, they also have enough energy and they're lined up correctly. This is very similar to how a high five works. Your hands have to be lined up and you have to slap with enough energy to make it a nice high five. Otherwise, it doesn't work. On a molecular level, if the particles do not have enough energy, they will come together and just bounce off and not react. On the other hand, if the particles are not lined up correctly, they will just come together and then slide off of each other. Nothing will happen. But if the collision is effective, has enough energy, and is lined up correctly, particles will react and form something new. Now, the overall rate of the reaction is affected by the number of effective collisions. By increasing the number of effective collisions, the rate of the reaction increases. The subject of reaction rates is very important to real life. Many industries rely on the knowledge of reaction rates. Here are some of them: construction, anesthesiologists, paint manufacturers, food production, chefs, rocket scientists, nail salons, and drug manufacturers. In construction, you'd want to know about reaction rates to time how long it takes cement to dry. An anesthesiologist wants to know how much medication to give for surgery. Paint manufacturers use the knowledge of reaction rates in making their products. In food production, you'd want to know how much preservatives to use in food and when an expiration date might be. Chefs would want to know reaction rates for cooking and baking time. A rocket scientist would want to know how much fuel to put on a rocket. In the nail salon, you'd want to know what the drying time is for nail polish and also to use UV light for top coats on the nails. And drug manufacturers would want to know when the expiration date is for the drugs. So that's the end of our introduction to reaction rates. At this point, you should be able to define what a reaction rate is, list the indicators of a chemical change, and describe the collision theory and what makes an effective collision. What you need to turn in by the end of the day is a short summary of these slides in your own words and turn it in on Canvas. And then also complete the Edpuzzle that is located on Canvas. Reminder that everything is due by 5 p.m. today. In our next class, we will have an in-person check-in. Plan to meet for the first 20 minutes of your class period. As always, email me with any questions. I hope everyone is doing well.